Good morning, folks. I'm Mr. Hartzler, and I want to talk to you about inverse functions. And we need to get started with a little bit of definitions. So the inverse function is a set of ordered pairs where the x's and y's are switched, right? We just switch those things apart, and they look like this thing right here. F raised to a -1 exponent is what that looks like, but it's not actually an exponent. It's just the way we write this. It's the symbol for it. Again, not an exponent. Doesn't act like an exponent. Just looks like this. And some examples. So what's the inverse of f? I read this like f inverse. And if this is my original f, all I have to do is switch my x's and my y's. Remember, x always comes first, y comes second. I just need to switch those things. And it's a group of numbers. It's like a set or a bag of numbers, so I use the squiggly brackets. And then inside my coordinate points, each of these, so I have 3 coordinate points, I just switch my x and my y. So y is a 3. 2 is my x, so I literally just switch it. Instead of 2, 3, it's 3, 2. And the next one, instead of 5, 6, it's 6, 5. And my next one, instead of 7, 8, it's 8, 7. And then I end it with a squiggly bracket. Now, what's the original function if I'm given the inverse? Well, I already know these are switched, so I need to switch them back. I start off with my squiggly bracket, and then each of those, there's 3 of them, are set of parentheses because they're coordinate points. I need to switch my x's and my y's back. So instead of 5, 1, it's 1, 5. Instead of 2, 6, it's 6, 2. Instead of 5, 4, it's 4, 5. That means, too, my domain and my range for this switch. My domain for f, so here, my f, the domain is, squiggly bracket, all of my first things, right? 2, 5, 7. If I'm looking at my inverse function, the domain of that, it's still all of my first things. It's still all of the x coordinates, but they have just been switched now. So it's 3, 6, and 8, which is kind of neat because that's actually the range, or my y values, my outputs of my f function. So looking at the original, what was the second part of each parenthesis? 3, 6, 8. And then my inverse function, what's the second part of each of those parentheses? 2, 5, 7. So if you'll notice, for my domain and my range, for inverses versus the original function, those two things are switched. It's pretty great. Let's look at the next one. So finding the inverse function, how do I do it? If I'm given with equations and stuff, I switch my x's and my y's, right? That's my number 1. And then my number 2 is to just solve for y. Let's do some examples. So here, I switch my x and my y. So now it's x equals 3y plus 1. Now I have to solve for y. So I subtract this 1. So now x minus 1 equals 3y. Let's divide by 3. And then there's a couple ways I could write this, right? Now it's x minus 1 over 3, or I could split this up, right? What's x divided by 3? Well, 1/3 x. And what's 1 divided by 3? It's my 1/3, and that equals y. But it's not actually y anymore. Those are actually my inverse functions. So I got to switch out that y with an inverse function. Now let's look at the one on the right. This one's a little bit different, right? It doesn't start off with a y, but you know f of x is the same thing as y. So that's like 1y equals 2x minus 3. I need to switch them. X equals 2y minus 3. Solve for y. So I'm going to add 3. Then I'm going to have to divide by that 2 that's in front of my y. Dividing by 2. It's the same thing as last time. If I usually like to be able to graph this later, so I divide each piece by that 2, and I get x over 2, or 1/2 x, and then plus 3/2 equals, and this is now my inverse function. Since it started off with an f of x, I'm going to give it f to the -1 of x, or f inverse of x. So there's that one, and there's that one. Let's check out the next one. These are a little bit harder, right? I've got x squares and I've got square roots. I need to still do the same rules, right? I'm going to switch my x's and my y's. Then I need to solve for y. So I'm going to add 3. X plus 3 equals y squared. I need to get rid of that squared. To do that, I need to square root it. So I square root both sides. And when I square root something squared, they actually cancel each other out, and I'm just left with my y. But remember, it's actually my inverse function. Now this one's a little bit different. Instead of that f of x, I know I need to put a y in there. So I'm going to just swap out my f of x with a y. Now I need to switch my x's and my y's. So that's x equals square root of y minus 1 and then plus 5. I need to solve for y. I have to do the stuff outside of my radicals, my parentheses, and all that stuff first. So I'm going to subtract this 5 over. Subtract that 5 over. X minus 5 equals square root of y minus 1. I need to get that square root canceled. So just like in the last one, to get a square root to cancel or a square to cancel, I have to do the other thing. So instead of square rooting it, I need to square it. And I'm going to do the same thing on the right side of my equation. Or sorry, the left. X minus 5 squared equals, and then over here, the square root and square cancel. I have to add my 1. X minus 5 squared plus 1 equals y, or my inverse function. Very cool. And last example, I need to graph my inverse function. So first, this is my original. I have to find my inverse. The original is already graphed. So I need to swap my x's and my y's. Then I need to solve for y. So I'm going to subtract my 3. And then I need to get rid of this 1/2. So I multiply by its reciprocal, or like that thing flipped. So instead of 1 over 2, I'm going to multiply by 2 over 1. I'm going to do that to the other side as well. So 2 over 1, that's the same thing as just 2. And I'm actually going to distribute that in. So I get 2x minus 6 equals y. And remember, that's my inverse function. And let's graph that. So I have negative 6. That's my y-intercept, right? Because this is like mx plus b format, my slope-intercept. So I'm going to plot that negative 6 on my graph right there. And from there, I have to go up 2 over 1, up 2 over 1. And I'm going to do this a couple of times just to make sure I get a nice clean line. And you'll also notice they kind of cross right there. Nice. And let's try and connect those dots. Cool. The nice thing about these graphs is they actually always look kind of like this. Tilt your head. For me, it's to the right. For you, it'll be to the right. But my webcam might look wrong. Right? So there, I'll fix my head so that it matches. Turn your head 45 degrees so that it matches with those graphs. And you see how it's symmetrical? That's important. It has to be symmetrical. I'm actually going to go to the next slide. Look at this one. I've graphed them real nice and pretty for you. The blue line or the blue lines are always going to cross somewhere on that axis, on that red line. And the graphs are going to be symmetrical. So if I turn my head just a little bit, right, they should line up. It should, I like to compare this to like a little butterfly, right? It should be symmetrical right there. That's one of the ways you remember symmetrical. Left side looks like the right side. Well, you got to cock your head a little bit to make that work, but it should always look like that. The graph of the original and the inverse function are always going to be reflected over the y equals x. And I picked a color you can't really see. Y equals x. That's what we're going to be graphing it or having it reflect over. And that's just because we swapped our x's and our y's, which is kind of neat. Alrighty, folks, thanks for watching. Have a great day.